Hello, today I'm going to be showing you how to build this, a 10-inch FPV drone for under $200. To accomplish this, we're going to be buying the parts off of AliExpress and then using a blend of brand name parts as well as no-name brand parts in order to get the best value for your money. Links to the parts I'm going to use are all going to be in the description below. Now, before we get onto the build, let's actually do a little bit of a size comparison because it might be kind of hard to tell just how big this is. So let's put this off to the side and let's bring out a 5-inch freestyle drone. Look how small this 5-inch drone looks compared to a 10-inch drone. This is absolutely crazy. Just the size of the propellers alone. So in your head, you can think that, a 10-inch prop is twice as big as a 5-inch prop. But once you actually see it in person, you could just see the huge difference in mass and just how big this 10-inch drone is. It is absolutely nuts. So coming up, I'm going to show you the parts I used, the build, and then the flight. Let's get into the parts we're going to use to build this 10-inch FPV drone. So first up, the frame. We're going to be using the Mark IV V2 10-inch frame, and this can be found for under $25 on AliExpress. And even for this really cheap price, it has some great features. One of the best things I like about it is that the press nuts are pre-installed. So you can see I have the flight stack mounting screws just lightly screwed into there right now. So the press nuts are already pre-installed. You don't have to press them in yourself. And number two, they are actually recessed flushed into the carbon fiber, which is a really, really premium feature that even more expensive frames don't have. So that is like a really good premium quality feature. Now, one downside for the frame is that it doesn't have any kind of GoPro mount or 3D printed accessories. We can use the 3D printed accessory kit from the 7-inch version, and that'll work on the arms as well as the little antenna mount, but the GoPro mount won't fit, and it's just really hard to fit a GoPro on here and the battery as well. So for this build, we will not be mounting a GoPro on it. If this frame isn't really to your liking, then stay tuned for another video where I'm going to be building another 10-inch drone using the Axis Flying Manta frame, which will fit the DJI O3 Air unit. For the motors, we're going for a generic 3 115 900 kV motors, and you can get a full set of 4 of these motors for around $50, which is absolutely crazy. That's the main reason why we can build this 10-inch build for under $200. These are going to come in a bunch of different brand names or just unbranded, and I don't think it really matters which ones you get. I think they're all coming out of the same factory, so just pick up the cheapest set of 4 motors that you can find. Links to all of these will be in the description below. For the propellers, I'm going for 10 by 5 by 3 props. I'm using the name brand HQ prop ones. There are also unbranded ones, and you can pick them up for about $7 for a full set of 4 props. For the flight controller and ESC stack, I'm going for the name brand SpeedyBee F405 V4 and the 55 amp ESC with the heatsink. The 60 amp ESC with the heatsink will also work. I really recommend the name brand one because, to be honest, I first started this build using the classic no name brand F405 stack that I used with my 7-inch build. And to put a long story short, the ESC failed, even though it's technically rated for 60 amps. And that's why I'm sticking with the name brand SpeedyBee flight stack for this serious 10-inch build. Either the F405 V3 or V4 flight controller, either one should work just fine. And for the speed controller, I think we should really use the one with the heatsink on it. So I have the 55 amp with the heatsink, and they also sell the 60 amp with the heatsink as well. For the analog video system, I'm going for the tried and true Rush Solo Tank video transmitter and the Rush Cherry antenna. This thing is made out of all aluminum and it only costs around $30. You can get video transmitters that are cheaper than this, but I think the value for the money, the Rush Solo Tank is really the best in the game. For the camera, either the Runcam Phoenix 2 or the Cadex Ratel 2 will do just fine, and you can find these for around $20. For the RC radio protocol, we're going for Express LRS 2.4 GHz, and I'm using a JHE MCU receiver, which you can find for under $10. And I also saw that SpeedyBee recently came out with a good affordable option for under $10 as well. And if you don't already have a radio, I really recommend the Radio Master Pocket Express LRS version. It's around $60, and they just released a Crush version of it as well, which comes in a whole bunch of different colors. And the main reason why I use it is that it's built like a tank. It feels really sturdy in the hands. Lastly, for the battery for this drone, I recommend something around a 6-cell 5000 milliamp hour LiPo. Now, I don't actually recommend buying LiPos off of AliExpress because the shipping can get really messed up with these really big LiPo batteries, so I recommend buying locally. This size of LiPo is really popular with RC planes and 8th scale RC cars, so you might want to check around your local shops for batteries for those. Now it's time for the build. I always recommend doing a dry fit of as many parts as you can together before you actually get the soldering iron out and solder things together, especially in this case since these lower cost drone frames don't actually come with instructions, so you kind of have to figure out the screw sizes and everything on your own. This one wasn't too bad once I pulled up the listing on the AliExpress page and I used the pictures as a reference to assemble this frame together. As a part of this process, we have to figure out which way the battery leads are going to come out, and because the 10-inch frames are so big, I'm deciding to route the battery leads out the side of the frame. And while we're at it, instead of using the stock XT60 connectors that come with these stacks, I'm going to be upgrading them into a larger XT90 connector with larger gauge wires. This is because we're putting a lot more power through this drone, so it'll be safer to use the larger connector. Soldering these big connections is definitely going to be the hardest part of this drone build, so I think it's really important to start off with the right tools first. So for soldering iron, I really recommend either a pine sill, which is what I'm showing here, or a TS100. These irons have temperature sensors that are built into the tip, and so they react really fast and respond quickly to changes in temperature, so you can solder both big connections and little connections really well. And make sure you pick up 2 different tips. One, the stock tip, the small conical tip is good for small connections, and get a big flat tip for the battery and motor connections. So the first soldering job is the capacitor, and now I'm soldering the capacitor to the bottom of the battery pads, and I'm later going to twist the capacitor up to move it out of the way, and that'll also leave some room for the battery wires to be soldered on the other side of the ESC. And before soldering it in, just double check, do a dry fit of where the capacitor and battery leads are going to come out of your frame. Since I want the battery leads to come out the side of the frame, you can see I'm soldering the wires at a little bit of an angle. This is definitely the hardest soldering job because the battery pads are the largest heat sinks on this ESC, and so it's going to take a lot of heat to get the solder to melt properly. Once that's done, it's time to solder the XT90 connector to the battery leads, and once again the dry fit will really help in getting you to figure out the right length to make the wires. My wires are about 6 inches long. And if you don't feel comfortable soldering these big connections first, I definitely recommend just practicing. Like, you can buy a big pack of connectors and lots of wire and just practice making these big soldering connections. Next, it's time to solder the motors to the ESC. Now, I'm opting to use these connectors. These are called MR60 connectors. This will allow me to easily swap out the motors or the ESC if needed really quickly, but the downside is it'll just take a little bit more time to solder because there's more solder connections to make. This is completely optional if you want to use connectors or not. You're totally fine doing a direct wire solder between the motor and the ESC. Next, it's time to install our flight controller onto the stack, change our soldering iron tip to a smaller one, and then begin the process of soldering our components to the flight controller. The first one I'm starting off with is the VTX, the rush tank. I'm going to be putting the full wiring diagram in the video description below so you can follow along as I wire it up. So the VTX requires 4 lines. It needs the red wire, which is 9 volts, ground, which is black. It needs the video signal, and then finally the data line. Next, it's time to solder in our Express LRS receiver. This requires 4 lines, ground, 5 volts, RX, and TX. For our analog camera, we just need ground, 5 volts and signal, and that's it for all the soldering. Next, it's time to physically mount everything into the frame, starting with the VTX. Now, in the 7-inch build video, I used M2 screws to mount it and screw it directly into the 7-inch frame, but for this 10-inch build, I'm being a little bit lazy, and I'm just going to use a double-sided sticky gel tape. This should also flip the VTX around so that the cooling heatsinks are facing upwards, so I think that might help it cool a little bit better. And frankly, the gel tape holds it just fine. To mount the antenna, I'm using the 3D printed accessory kit that's originally designed for the Mark IV 7-inch frame. It works just fine on this 10-inch frame as well. And once that's done, screw in the camera into the camera mounting plates using the included M2 screws with the camera. And for the Express LRS receiver, I just tuck it in nicely and secure it with zip ties. To tidy up the motor wires, I use this fabric tape that Nick Burns recommended. The next step of the build is the beta flight setup for the drone, but the thing is that takes a lot of time, so I'm going to be moving that to the end of the video for those of you who have the drone physically in front of you and want to follow along. Instead, for now, let's pretend you finished that. So after setup, it's time to button up the drone, screw it all together, go over all the screws with thread lock. This is really important. If a screw is screwing into metal, you want to use thread lock to secure all the parts so it doesn't vibrate out during flight. That's very important for a huge 10-inch drone. You don't want that crashing down. Next, install the props and then start mounting the battery. Make sure the battery is very securely mounted and the wires aren't going to get cut by the props. For the very first test flight, if you know how to fly without FPV goggles, so basically just looking at the drone and flying it like that, that's always a good idea, so you can do a quick hover to make sure everything is configured properly. If you don't know how to fly line of sight, that's fine. Don't start with the 10-inch, just go with the FPV goggles like what you're used to. With these test hovers, you can make sure no wires are going to get caught up in place. You can make sure nothing's overheating too bad, and you can later on, you can look at the DVR footage of your goggles to make sure that the video system is all working properly before you strap the goggles on and are at the mercy of your build. Alright, now it's time for the test flight around the pond. Of course, if you have a nice big open grassy field, you should definitely do that. You shouldn't try to fly around a pond, but I'm somewhat limited in the areas I can fly, so I'm just gonna have to deal with hopefully not crashing this into the pond. The biggest drawback for this frame is definitely the lack of a proper GoPro mount. So for this flight video, I'm only going to be showing you the recorded DVR from my goggles. I hope to make a different 10-inch video soon with maybe a DJI O3 Air unit so we can get a lot better footage from it. One of the first things I noticed when taking off was just how much power this thing has. If you look at the top right, you can see my throttle level, and I am cruising at 20% throttle. That is such a low throttle value, and if you look at the bottom left, the amps, I'm only pulling like 10 amps. That's like on par with a 5-inch 6S drone, and it's crazy that this 10-inch drone is drawing that little amps, this little throttle, just to stay in the air. That shows you how efficient propellers can get as you scale them up bigger. The reason full-sized aircraft can fly for hours and our drones can only fly for a few minutes is because basically bigger blades are a lot more efficient at creating thrust than smaller blades. But even in our little drones, the difference between a 10-inch drone and a 5-inch drone, there's such a huge increase in efficiency. And so I'm really excited what we can do with these big 10-inch drones because there's just so much room to add more stuff to it. So this is on my 4500 milliamp hour 6S pack. It has so much thrust left over. It has so much flight time capability. Spoiler alert, this flight, I'm not going to be showing the flight in its entirety because this flight lasts over 15 minutes and there's still plenty of battery left to spare. Yeah, this thing is an efficiency beast. So I'm wondering what happens if I could, double up the batteries. Will I get 30 minutes of flight time on it? I don't know. How fast can this thing go? Maybe I'll put a GPS on it and see how fast it can go. Overall, with these big 10-inch drones, it just looks like there's just so much flexibility in what you can add to it compared to our little 5-inch drones where you're pretty much limited to what you have. You can maybe add a GoPro on it, but you can definitely feel the weight of the GoPro. With this 10-inch drone, it just seems like anything is possible. Now, at this point in the flight, I'm 8 minutes in, and I thought I would have landed already, but clearly I have a lot of time left, so I got a little bored and decided to fly directly over the lake. I only did this once before I was like, you know what, I'm not gonna push my luck. Another point I want to bring up is just how quiet this drone is in its current configuration because it's using so little throttle, because the thrust to weight ratio is so good and efficient. This thing is absolutely it's so quiet, it's almost silent once you get like 50 feet away from you. It's absolutely crazy, so I'm actually going to bring it in closer to my GoPro recording so you can kind of hear how quiet it is and how quickly it drops off. Also, as I'm bringing the drone in closer to me, I'm noticing how stable this thing is in the wind. Because of its size, it doesn't get affected by wind gusts as much as a 5-inch drone, and so it feels really nice and stable to fly. Overall, I'm really pleased with how this build went. This thing flies so much differently than a 5 or 7 inch drone, and it has so much more potential to it, but the fact that we can still build it for the same cost as a regular 5-inch drone is pretty crazy. So if you're interested in building your own 10-inch drone, I hope this video helps you. Also, if you aren't already subscribed, I'd really appreciate a subscription to my YouTube channel. Coming up next is going to be the full Betaflight setup. Thanks for watching. Alright, it's time to do the Betaflight setup for the 10-inch drone. So the first thing I'm going to do before I plug it in is I'm actually going to plug in the main flight battery. The order of operations does matter. So we're going to power on the entire thing first. I'm going to make sure my VTX is on the lowest power mode. There's the power LED. It's green, which means it's at 25 milliwatts, so that's not going to overheat. That's good. And now I'm free to plug in the USB. All right, and we're connected. So first thing I want to do is make sure the orientation of the board is correct. So I'm going to start tilting the drone. I'm going to make sure that it tilts properly. So tilt forward, yep. Tilt back, yep. Tilt left, tilt right, yep. And rotate. Okay, so our board orientation and everything is all good. Next, we're going to go over to the motors tab. And I'm going to make sure that the way the motors spin is the right direction. So first we're going to do the motor order. So let's go to the reorder motors section. No props on. The battery's plugged in. So let's go ahead and do that. So the bottom right motor is spinning. It's pointing that way, so I'm going to click that one. Top right, bottom left, top left. And we hit save. Cool. All right, next we're going to go into the motor direction wizard. So once again, we're going to do that. I'm going to make sure the motors are spinning the right way. I do props in, so like this motor will be spinning in this way, that motor will be spinning in towards the front that way. And let's do them individually. So I'm going to click motor 1, which should be this, and I'm going to lightly put my finger on if I can't tell which way it's spinning. So here. This one is spinning the right way. It's spinning that way, so that's correct. Number 2. This is spinning the wrong way, so I'm going to hit reverse on that. There we go. So now it's spinning the right way. This is spinning the wrong way as well. It needs to spin this way. So we hit reverse on that. That's good. And then number 4. This is spinning the wrong way. Let's hit reverse. There we go. Now we just hit close, and that should be good. So the next thing I want to do is I want to set up the VTX. So the VTX, I have the control set up to UART1. So over in the ports section, I'm going to set UART1 to be the VTX, and the rush tank is a smart audio protocol. So I'm going to do UART1 smart audio, save and reboot. Next, let's go to video transmitter. We see device ready is true. That's great. We don't have a VTX table here. I'm going to upload the VTX table for the Rush Tank Solo. I'll drop a link to that in the description. It's this one, Rush Tank Solo Smart Audio 2.1. We'll do that. And we'll go ahead, and I use band A, channel 6. For now, we'll just set it to 25 so it doesn't overheat on the bench, and everything else is good to go. Let's hit save. All right, and now we're free to go to the OSD and start setting up the OSD. Okay, so by default it goes into auto mode. We want NTSC, and now we can start configuring our OSD. And I have a little monitor here. This is a small little analog monitor, and you can already see the warning is there. So let's go ahead, and I'm going to start putting the elements I want on the display. So first of all, I really like using the artificial horizon, so we're going to add that. So there it is. Oh, it's already centered. That's amazing. Artificial horizon there. We want battery average cell voltage as well as the current draw, and I also like the amp hours draw there. So I like to keep the voltage right in the middle so I don't have to move my eyes to see it as much. And let's get these two off to the side. There we go. What else do we want? Oh, let's do craft name. This is going to be the 10-inch. I'll put it down here at the bottom. I have to remember to update the craft name. We want our flight time. Oh, that's the on time. We want flight time over there. Next, we want our VTX status. And maybe we want the link quality as well. So that'll give us some information about our RC link. And throttle position is also fun to have. Okay, so our link quality, this is stuff that isn't too super important, so I'm going to stick it at the top right. Stick my VTX settings at the top left. Let me actually move this down a tad. I'm going to move it down just a tad, just in case it goes off screen. Throttle position is not too important. We could stick it up at the top. Flight time, I like to put it at the bottom. All right, and that's the basic OSD setup that I like to do. That should be all good to go. So let's hit save. Now all I have to do is set up the receiver. I have it set up to UART, the receiver set up to UART2. So let's go back to the port section. And UART2 is already set up to serial RX, good. And let's go into the mode section. And let me grab my radio so I can go ahead and set up the modes. All right, finally we have to set up the receiver. So first let's turn on the transmitter.
Welcome to HTX. Switch warning, disarmed, acro mode on.
Let's power on the drone. And now I'm going to wait 1 minute for this blue LED to flash really fast, which means it's in Wi-Fi mode, which is at the point where I can enter in my binding phrase. All right, the blue LED is flashing fast, which means it's in Wi-Fi mode. So let me go over to my wireless connections and connect to the Express LRS receiver. It then opens up 10.0.0.1, and here I can enter in my binding phrase, which I'm personally using the word pineapple. Hit save and reboot. And now my radio should show as connected once it reboots. Let's see. There we go, we have a good connection. Cool. So let's head on over back to Betaflight. And let's plug it in. And hopefully we can see that it's worked. We're plugged in. Let's go over to ports just to make sure, yeah, UART2 is serial RX. Let's go to our receiver, serial via UART, and ooh, we don't want S-Bus, we want Crossfire. Because Express LRS uses the Crossfire protocol. So we're gonna hit that and do save and reboot. All right, let's go back to the receiver tab and let's just make sure it's recognized. Let's spin the sticks a little. Nice. Okay. So the receiver is working properly, as we can see here. Now it's time to set up the modes. I have arming, you always want on aux1. And then I use angle mode or stable mode on aux2.
Angle mode, acro mode.
And those are really the only modes I fly on. So let's go to modes. And first, let's make sure there's nothing enabled by default. Yep, everything is off. So we're going to do add arm to aux1, and we want that all the way up here, and we want angle on aux2, and I want this upper half. So let's give it a quick test. So if I hit armed, disarmed, and then angle mode.
Angle mode, acro mode.
Cool. So that's all I want. It's already saved. It's good. And with that should be all of it completely set up. As one last little sanity check, let me make sure the motors are spinning properly. So let me hit motor 4 again. I'm really paranoid about the motor settings not saving. That is somewhat of an issue with Betaflight. So let me go ahead, and I understand the risks. I'll test motor 4 again because I know I had to reverse that at one point. Let's see if it saved that. Yep. So that's correct. Let's actually just check them all real quick. Motor 3 is correct. Yep. Yep. Motor 2. Yep. Motor 1. All right, everything is good to go. Now it's time to take it for a test flight.